60 frames a second, it can detect cars, it can detect pedestrians, stop signs, it has to do it in all kinds of weather. It can semantically segment the image and determine the objects. The purple is drivable surface. With that, it can draw boxes around cars. It knows what cars and vehicles are around it. It can segment lanes. It can use that and check the blind spot to change lanes, for example. And it can categorize the drivable surface there in the middle. The white lines are off the road. The yellow lines are things that you really shouldn't hit. And the red lines are things that you really, really shouldn't hit. It's the Palo Alto Stanford Mall, by the way. It's funny. And you can put all that together, and that's fantastic. This all happened in the last 5 years. 2012 was 0 hour. It's amazing. But what you would have to do with that is you'd probably wrap it, most of us are engineers, in some if-then-else code saying, well, if the sensors tell you there's a car and the velocity you should be stopping but you're not, stop the car. If you try to change lanes, don't let them if there's someone in their blind spot. But the next phase is much harder. It's how would you make an autonomous driving car, and what you do is you make the algorithm behave or mimic an ensemble of good drivers. I emphasize an ensemble of good drivers, not an average driver, which today, with all our distractedness, would be pretty bad. That's the whole point that we're trying to do. And so what's fascinating is that the car, and this is an Nvidia test autonomous driving car using our hardware software developer kit, it learns like your son or daughter would at 16. It starts in a parking lot, and it's pretty bad. And it gets confident in the parking lot, and mom or dad says, well, or the driving instructor, let's go out on the road. Sort of halting at first, nervous, not confident, but pretty soon you're navigating with confidence challenges as you learn from more examples. And pretty soon, the autonomous driving car is able to navigate things we never taught it. We never trained this car to navigate a construction roadblock diversion. We never said you can go off the road. We didn't say if off-road, then else, if the angle is this and the grass is smushy. It did it on its own. So in the algorithm world, that ability to generalize, called generalization, to solve new problems that you've never seen, that is the hallmark of intelligence. This is really rather remarkable, and obviously the industry has to regulate and make sure that it's safe, but it's pretty interesting. Now,